So good morning, everyone, and welcome to the webinar with Esri and Epic Games. My name is Jeff Model. I'm the founder at CG Architect, and we'll be managing the webinar this morning. So today we've got three amazing presenters who will be showing us how designers and visualization professionals use CityEngine and Unreal Engine to explore and communicate urban design projects. In just a few minutes, I'm going to be handing over controls to Chris, but first I wanted to introduce our three presenters today. First, we've got Simon Hagler from Esri, a software developer. We've got licensed architect and senior associate Chris Zug from HOK. And finally, senior product manager Pierre-Felix from Epic Games. So I'm just going to explain a few of the formalities of the webinar, but while I do that, I wanted to pop up a quick poll question and have all of you answer that. So let me just pull that up here. Basically, what we want to ask you, and actually, Chris, can you just hand me back presenter again?
Sure, hold on one sec.
Sure, and I'll launch the poll here. There we go. There we go. I got it. So if all of you, while I go over the kind of ground rules for the webinar here, if you want to just take a gander at the poll and answer, it would be great. So today's webinar is going to last about 40 minutes. And if at any time during the webinar you guys have a question, just use the question interface that you see in your control panel there. We'll be answering two questions live at the very end, but don't worry if we don't get to you during the live Q&A session. We do have a record of all the questions, and we'll definitely be following up with you via email afterwards. So with that, I'm going to probably wrap up this poll here. Might just give it a few more seconds, and then I'm going to hand things over to Chris. So Chris, I'm going to make you the presenter again. All right, Chris, that's all you.
Okay, thank you, Jeff. All right, we ready to begin? Should we go?
Yeah, go ahead.
Yes, so. Okay. Again, thanks. Thanks, Jeff, for having us. What we're going to talk about today is essentially basically kind of some workflows on how to get, based on how us as designers work, the tools that we use, and kind of how we visualize them. Really quickly about me, my name is Chris Zug. I'm a design technology specialist here at HOK, so that means I kind of handle anything that's interesting around building information modeling, visualization, urban design technologies, etc. I work for HOK. We're a global architectural and engineering and urban design firm. We've got 23 offices worldwide. I happen to work in our Philadelphia office. So to begin, we're going to talk about a few different, basically we're going to talk about workflow. Essentially when we're working on, there we go, urban design projects, for us, design communication has always been a challenge, right? Even in traditional planning processes, when they were on paper, you would work with these giant maps and things. And when we moved into the CAD realm, nothing really changed. It was still, a giant 2D color block map that our clients kind of had to envision what, kind of translate in their mind what these things meant and to understand what the city could look like and how it could develop. So, we're always looking for better ways. Typically at HOK, things start with obviously a sketch, like most things do. But the challenge is, all right, well, how do we get it from this kind of sketchy color block diagram into something that's we can visualize and we can actually show our clients. So, how do we get there? Well, to begin, we can talk a little bit about our design process. It kind of always starts with the site boundary, and then we look at topography and we bring in some satellite imagery. We start laying out our roads, our street network, and determine where's our primary, secondary, and tertiary roads. And then we get into zoning and building our transects and determining, how we want this thing to actually look. Now, there's a video playing. It's probably pretty choppy, so I'm not going to talk directly to it. But the long and short of it is, we needed a tool to kind of aid our design process, right? So what is our design process? Essentially, the way we work right now is things are done, they kind of start either in CAD or they start in Revit. Generally what you're seeing on the left-hand side, that's just a Revit drawing, which is technically just an area plan, right? So we're kind of drawing these spaces and using the area tools to actually generate these shapes. But the important thing is they're denoting transects. So we use a smart code. That's not, exclusive to HOK. It's actually quite a common planning tool nowadays. But what it is essentially it defines, instead of defining zones as far as what can be commercial and what can be residential and what can be industrial, it really defines the kind of feel of the area. So a T1 would be completely natural and untouched. T2 is more rural. T3 gets into suburban, and T4 and T5 we get into some more mixed use and urban areas, and then T6 you could think of as the kind of core, right? The high-rise city center. So at a high level, we go about defining these areas. And then from that, we kind of use those transects to drive how these buildings take shape. So how, not so much this can be a business here, or this can be a residence here. It's more about the shape, and that kind of follows what it actually is. So we determine things like setbacks, minimum maximum floor heights, even we start to shape the actual volume of the space, or the massing. So setting it back, whether it has a balustrade, whether it has a balcony, whether it has a promenade on the first floor, and even getting into plantings and everything else. And we extend it also to our street networks as well. So we may in the beginning just be laying out center lines, but we kind of understand we kind of determine what those primary roads look like, what those tertiary roads look like, secondary and quaternary, and even get into quintentiary, I guess that's the word, fifth level. So again, we do it by rules. So, we may have 3 or 4 different sections for a 45-meter road. And, there are certain rules on when that joins another 40-meter section, what happens. So because this is all rule-based, we would typically go ahead and try to kind of understand what that potentially could look like. So for, traditionally it's been a manual process for us. We would draw these little kind of shape diagrams down the bottom here manually, either in Revit or Rhino or SketchUp or whatever have you. Kind of to try to kind of understand what the city could look like. But again, it's not reality, right? It's just, one person extrapolating those rules. So there could be many different ways. We started to look at CityEngine to help us do this. So CityEngine has a really, really robust programming language called CGA, which Simon will show a little bit later. It allows us to kind of translate these smart code rules into actual building rules on how lots generate and how buildings generate. So it's become extremely useful for us. So I'm going to let this video play. It's probably going to be a little choppy, so we'll just have to kind of bear with that. It's a notion of the nature of webinars. But it allows us to kind of go through in a very iterative, quick process, understand what our ramifications are for changing a transect or changing the rules within a transect. So we can quickly regenerate the entire city based on a new set of rules, or even, that's the quarter area, but we can even get into individual blocks if we wanted to. So sometimes we get in and we go in and we start to place social infrastructure like firehouses, police stations, hospitals, schools, administrative areas. So we can start to dial in these specialty areas and determine exactly how a building might look, or exactly how an individual lot may look. And what's interesting about this is once we start manipulating this data on this level, the kind of randomness, if we go to regenerate the entire city with a new set of rules, this stuff sticks for us, so it stays that way. Now, to kind of explain a little bit more about how CityEngine works and to be able to show you guys this in a little more detail, I'm going to pass it over to Simon, who is going to take it from there. So Simon, I'm going to pass it over to you very quickly.
Thank you, Chris. Okay. So, hello everybody. I'm Simon here from the Esri R&D Center in Zurich. I had the pleasure to lead the development efforts for the Unreal exporter for CityEngine from this side, and I have the honor to walk you through a short live demonstration of this new Unreal exporter in CityEngine 2017.1. So before we do that, I would quickly like to take the bird's eye view here. So this is basically how the Unreal workflow looks like. So we have actually it's kind of a common CityEngine workflow with just a new exporter on the right-hand side here. So on the left-hand side, you usually start with your data sources. You have maybe shapefiles, file geodatabases from Esri, or you have OpenStreetMap data, or maybe data from our ArcGIS cloud service, or many different other sources. And then in the middle here, this is basically the traditional CityEngine workflow. You work on your terrains, you work on your street networks, you use the CGA language mentioned by Chris before to generate your building models. You iterate on that, and when you're ready, you export that into Unreal. So let's jump right into CityEngine. So I have a beta here of CityEngine 2017.1. And I would like to first quickly show you how you usually start such a project. And one of the best ways to start a project, an urban design project, I should say, is using the get map data function. It's basically a little data aggregator, which allows you to download from various places. So let's say I fly to Zurich here. So here I am, downtown Zurich. I zoom in a bit for the sake of time, a bit more. In this tool, I can set an extent. I'll choose on the right-hand side the resolution of the base map, the resolution of the world elevation. These are two services from the Esri cloud platform called the ArcGIS Online, and we also can pull from OpenStreetMap. So now the Get Map Data wizard is downloading these 4 sets of data: the satellite imagery, the elevation, the street networks, and some building footprints, including their attributes. So now the OpenStreetMap importer asks me some options. I'm gonna make that a bit faster by selecting some options. And here we go. Here we have the scene. So we have the terrain with the satellite imagery. Go a bit slow to allow the video to catch up. Here we have the street networks with the crossings and all the attributes. And last but not least, here we have the building footprints, also with the attributes. So let me hide that. All right. We also assign a default rule on these shapes, which quickly gives you a first visualization. And we also have some built-in designs. So I can switch those, for example, to a Zurich template. And if we wait a couple seconds, we actually see how CityEngine regenerates all the models. And we see now something which more or less looks like Zurich. It's of course not the real Zurich. Also adding the terrain again, so it looks a bit more natural. So this is a really nice way to start with a project, with urban design project like that. Now, let's switch over to a bit more involved demo. So I have the urban design demo scene from HOK, from Chris, which they kindly designed for us. So you see, this is a scene with about 10,000 buildings. And let's fly in to an area of interest here, where I'll wait for the video to catch up. All right. So I would like to walk you through a number of usual edit steps we do. I'm not going to show any CJ code at this point because the time is not enough. It's also a bit hard to see on a webinar, but I would just like to show you a few of the local edit steps you can do, which quickly allow you to tune a scene like that. So one of the first things you might want to do is to actually edit some streets which might have been placed wrongly or in the way. So let's move one of the crossings, and let's wait for CityEngine to do its dynamic layouting of the blocks, shapes, and also regenerates the buildings. like this. So you see, this is really handy. All the layers in CityEngine are dynamically connected. So if you edit one layer, all the layers above will automatically adjust actually. So now let's see, the next edit step we might want to do is to make this park here in the middle a bit nicer. So we have again these handles here. So one of these handles allows us, for example, to change the park to something a bit more natural, like this. And maybe we also want to increase the level of details of the trees a bit. So this already looks much nicer. And last but not least, one of the most important steps, of course, is to deal with the buildings themselves. And I will just like to show you how you can edit the height of the building by grabbing this handle here, which internally, I should mention, is attached to a CGA rule attribute. You can actually specify for which of the CGA parameters you would like to see visual handles, and then you can design and set this up, and it allows you to quickly edit buildings like that. All right, now let's assume we are happy with what we are seeing here, and let's do a little live on-the-air Unreal export to see how that works. So to save some time, I'm only going to select 3 items here: the park, the street, and this building. I'm choosing the file export model item, and we see in the middle, we see here the new Unreal Engine export, which is currently in a beta state. We deliberately kept the options to a minimum to make that workflow easier for you. So let's just set up the name, hit the center button once more to avoid confusing the Unreal Engine with big projected coordinate data. And we click on the finish button to let it export. So this should only take a couple of seconds for this small scene. And we are done. Now, on the left bottom corner of my screen, you should see a folder and a file, and this is actually what has been exported by the new exporter. So we have a folder with the assets, and we have a uDatasmith file, which is basically a description of the whole scene. I now move my CityEngine a bit out of the way here, so I can pull up the Unreal Engine in the back. Here we go. CityEngine once more. So now we have on the left, we see Unreal Engine in the back, and we have CityEngine in the front. All I'm doing now is I'm dragging over this Datasmith file into the Unreal Engine. The importer of Unreal pops up. I just use the default values here, and if we are patient for a couple of seconds, we should see our building with the street and the park eventually. So Unreal now does a lot of optimizations to do all this fast rendering magic. And in a couple of seconds, and an autosave. Let's give it a second. We should see the scene. And we are right in the middle of it. So let me fly out a bit. Oops, once through the building. And you see actually the scene. So what we did here is we will provide you with a CityEngine template project where all the shaders and the light setup is like you see here. So you should have a quick start, so to say, and then you can go in and tune the light and the shaders to your liking, obviously. So I would like to, at this point, so Pierre-Felix from Epic will show you some more from this scene. I would just like to highlight some more technical aspect at this point, which is how the CityEngine entities translate to the Unreal entities. So in the table on the upper left side here, we see how these various entities translate. So the start shapes in CityEngine will actually translate to folders inside Unreal. So on the right-hand side, you see the shapes here. And the individual models will be attached as static mesh actors with this little house symbol here. And all the instances in CityEngine will be preserved, and the geometry created within CityEngine will be merged together and sorted by materials. And then on the lower, on the bottom part of this slide, on the left side, you see the master materials, which are provided via our template project, and the importer will automatically create material instances from that. So Unreal Engine actually understands CityEngine materials. And this is then how this scene looks in Unreal if we do a bit of a larger export. Now, I would like to close with actually one more slide. Excuse me. A couple of slides here. Some more examples from this scene. So I'm going a bit quicker here because Pierre-Felix will show that live. And I have one more image from the favela scene, which is done by our collaborators from Urban.io, Matthias Bühler specifically. He did that wonderful scene, which we also loaded into Unreal, and it looks really fantastic. So to close my part, I would just like to show you one more fun thing, which is a little game done by one of our interns here at Esri Zurich. And it's actually based on one of our example scenes, which you get for free with CityEngine. It's a little medieval scene. You can actually walk around with a knight. And it only took about 3 or 4 hours to set up this scene with all the lighting and the actors. So yeah, unfortunately, the frame rate is quite low on the webinar. Yeah, with this little fun interlude, I hand it over to Pierre-Felix.
Great.
So
Thanks, Simon.
I make you presenter like this.
Yeah. You guys hear me okay?
Yes, we do.
Okay. Great. So at this point, what you should see now is the Unreal editor. I have loaded that scene or that project from HOK. We have, in this case, used Unreal as a presentation tool. Think of it as if it was a mix between a game and a video playback system and PowerPoint. So in this case, for example, the model from CityEngine has been loaded entirely. We're talking about something like 20,000 objects or close to 100 million polygons, something along those lines. As you can see, all the data from CityEngine has been loaded with all the textures and materials and so on. And in this case, I am freely flying around the model. But there are other things that can be added to this experience, which is, for example, video sequence. So if you know, in this case, I programmed a button in a 2D UI to start triggering sequences. Maybe I should reduce this because it's not the video, so I'm not sure what's the frame rate. But I hope you get the idea. So Unreal allows you not only to see things interactively with a game fly-through mode kind of experience, but it also allows you to create camera sequences and trigger lighting effects and so on. So in this case, lighting is still live. So I have created a sun slider here where we can manipulate the sun angle while the camera is flying around. Other things that can be done is, for example, and I was mentioning PowerPoint. In this case, we have created a hybrid between video presentation and camera presentation, where the slide deck that you saw earlier can be actually loaded as an interactive presentation, while the background plate is actually playing back in real time. So, and this is still, this is not pre-canned video. As you see, I'm still manipulating the light. So things actually are happening completely live on my machine. Another thing that we have done in this project is that we have imported walking people, in this case from a product called Anima. So as you see, you can have people walking, video overlay, and so on as part of the full presentation. The other thing that we have done is that we've exported the model in two different modes. So one is the realistic mode, if you wish, and the other is actually more skeletal, where we are showing the same information, but with just volumes and color codes. So we've created a camera switchers that literally load and unload different state of the model, so we can visualize data in a different way. In this case, we've attached meta information with objects. So as you click on those entities, we're showing up a little flag with a name and square footage, area of that zone, and so on. So this is to demonstrate that in fact Unreal can be used as a way to present many types of data in the similar way. So I'm gonna shut this down and show you how this was actually created inside Unreal. So I'm gonna close this. How's that working? So in Unreal, we have basically all the data loaded in a world outliner. You can see that the data that came from CityEngine is well laid out in folders and names, recognizable names, and so on. We also have the ability to create sequences. So the video that you saw, or not the video, but the presentation that you saw early on was created inside the sequencer. So in this case, we have a full nonlinear timeline where we can start switching between cameras and define cool shots like drone shots like this, or camera cranes, and so on. So this is actually created inside Unreal with the sequencer feature. Other interesting aspect is, for example, if you look at all the data that came in, we have all the materials that were created by CityEngine. They come in just as defined inside CityEngine. We also carry over all the textures. In this case, there were a lot of cars and grass and roof textures and windows and so on. So this is all handled. And there's a couple more things to that. So for example, I made reference to the PowerPoint-like presentation. Well, Unreal allows for creating 2D UIs where you can create buttons, and those buttons are basic images that you load in, and then you assign them some logic and you tell them what to do. So in this case, we've loaded the images that we extracted from PowerPoint, and we created right and left arrows, and then we assigned logic to say, when this is on, show the image, and then play back the video in the background and blur the background, and so on. For example, this black square here is a placeholder for the video that you saw when people were walking in. The other interesting aspect is that Unreal is capable of loading Excel spreadsheets, basically. So CSV data, and we wrote some scripts to load that in, and in which you get the area as well as the names that were used in the presentation. So you don't have to hard code this into graphics. You drive the data procedurally, and how it's done is that by creating a generic piece of UI like this, where you assign data fields, where you say this text here will actually look up for the value contained in this column, and this text here will look up for value contained in the other column. So this is pretty much how this is all set up inside Unreal. So Yeah, so I think that that is ending my part of the presentation. I may hand it over the rest of the team as well for probably opening up a QA session, or maybe there's a wrap up.
Thank you very much, pierre-felix. Jeff here again from CG Architect. So if, we've got a number of questions that have come in here, so I'll probably grab the first one. And in the interim, if any of you have more questions, then please feel free to pop those in and I'll grab another one. And like I say, once, if we don't get to the two questions live during the webinar today, then we will be capturing all those and we'll make sure to get back to you after the webinar. So Simon, this question's probably for you. It was during your presentation. Trip was asking, were you able to extract the building footprints, the heights, and the roads from the base map and the elevation layer?
So the building footprints and the roads are actually coming from the OpenStreetMap servers. So we don't do any feature extraction at this stage. We basically use what the OpenStreetMap community has ingested into their database, and we have a bunch of built-in rules inside CityEngine which understand the OpenStreetMap annotations or attribute data. We try to interpret those. So, for example, they have something like a number of floors, and we assume a standard floor height and extrapolate the building height from that. I hope that answers this question.
Okay, perfect. I got another one here. This is from Budianto. It says, how do you handle a big metropolis city, for example, like New York, when you have a number of polys and a maximum RAM can handle it? Is there any way to do dynamic loading and unloading with some of the buildings streamed down from the cloud, for example, as would be needed in gameplay, depending on the camera location?
For CityEngine or Unreal?
It looks like this is for Unreal.
So in Unreal, there are different strategies related to level of details. So you can, and you will have to, in those cases, deal with level of details. There are tools to do object calling based on distance. There's also dynamic loading of levels. So there's actually already a lot of strategies to deal with these types of situations. So I'm not sure how familiar you are with Answer Hub or even custom support, but we will be happy to help out directly with those types of questions if you reach out to us through these channels.
Okay, Simon, somebody asked basically the same question for CityEngine.
Hey Jeff, I just wanted to add to that question.
Sure.
I mean, pierre-felix actually mentioned several tools. What we typically use is if you're looking at Unreal, you want to look into world composition and level streaming. That's your two main pieces that would help you there.
Yes, thanks, Christopher.
Okay, to answer for the CityEngine regarding streaming of big data. So CityEngine itself is actually more like an authoring tool. So we never aspire to like whole metropolitan area. What we actually focus on is authoring the procedural rules. So we usually work on a small subset of the scene, and then when you're ready to export and to go into your next tool in your workflow, you can then select all and do a batch export. So you don't have to generate the whole scene in terms of CityEngine models inside CityEngine. You can actually let the export do that building by building, and so your machine will not die at this point.
Okay. So I think we still got a couple minutes. So I know we said we were only going to do two questions, but I think we got enough time for maybe one or two more. It's got a good one here. Can Unreal integrate point cloud data from laser scanning sources like recap or points, etc.?
Out of the box, there's no solution. That being said, it's not that we're not interested into that. That is definitely the kind of workflows we're looking into in the future. In the immediate term, there is a third-party developer that solved that problem. It's called Neuralize. They have created a plugin for Unreal that display point cloud data, as well as a series of tools to clean up and optimize and play it back. So in other words, you'll have to rely on a third-party developer at the moment for that.
Okay. There's a question here asking about which version of Unreal accepts import of Datasmith files.
So Datasmith is currently in the beta program. In the moment, there is a beta program that you have to register to get access to. Our plan is to ship Datasmith with the release of the engine 4.19. In the moment, Datasmith file can be ingested into 4.17. But not as part of the free engine. It's more of a separate set of tools on the side right now. And in order to access them, you'll have to be on our beta site. Now, if you are a CityEngine customer, there are ways that we can certainly give you access to those tools, fairly quickly as well. So go to unrealengine.com/beta. That should point you to at least a registration page, and then get in touch with us directly or with Esri for being able to try it out.
Okay. I think we'll just do one last question here, and I think this is related to the video that we're seeing now. It's asking, how is the lighting handled? Is it built or is it preview mode, and how does it work over tens of kilometers?
In the moment, nothing has been baked. So because that model is so large, baking it will probably be a problem, and we didn't want to deal with that. So for the record, this lighting, all the lighting in that video, or actually that game, is live. So there's no baking at all, and it's running on my laptop. So that tells you a little bit about the optimization required. That being said, it's a very interesting laptop. It's a GeForce 1070 card, but it's not like it doesn't need to be a very, very expensive computer. So.
All right. Well, first off, I want to thank everybody for attending the webinar today. We've got a ton of questions here that have all come in, and obviously we don't have enough time to cover them all live, but as I mentioned before, we're going to be getting back to all of you with answers. We'll probably keep the webinar open after we end here just for a few more minutes just to capture as many questions as you guys may have. I want to end with one last poll, if you guys don't mind answering that for us. And I want to just thank our presenters today for presenting for us. Thank you very much. It was great.
Have a good day, everybody.
Have a good day. Thank you all.
Thank you.